quadratics, putting it all together. Okay, the whole reason for solving quadratics is not so you can solve a whole bunch of problems on a worksheet, but so that you can solve applications, real life problems. So we're going to look at some examples that are based on things that you know and you understand, but that can be solved using quadratics. All right? The big thing here, one of the most important things is you need to learn to draw pictures. So the width of a rectangle is 6 meters less than its length. If the area of the rectangle is 112 square meters, find the dimensions. Right, first off, draw a rectangle. Just draw a rectangle. Then the width is 6 meters less than its length. I made the length x, and so 6 less would be x minus 6. The area is 112 square meters. That doesn't mean that I square the number 112. Square meters is a unit of measure. To find the area, I know that this is going to be equal to the length times the width. And notice I made these not L and W, but I put them in terms of the same variable. The area, I know, is 112. I don't need the m squared when I'm doing my equations. And then it's going to be the length, which is x, times x minus 6. And you're saying, well, I don't see a quadratic yet. It's because you haven't distributed. You have to distribute the x and then subtract the 112. Now, because it's painful to write using a mouse, I've got it already written down here. X times x minus 6 is equal to 112. I distributed the x, subtracted the 112. Now I'm going to factor. Remember, factoring, okay, factoring would mean that I need factors of negative 112 that add up to negative 6. And since a is 1, I don't have to make it a star. Now, as a reminder, if you get stuck on something, negative 112, there's a lot of possibilities. And negative 112 is not one of our normal, just off the top of your head, multiplication tables. So if you need a little bit of help finding factors, you can go to your calculator and under y1, you're going to have the negative 112, and you're going to divide it by x. So y1 times x will equal negative 112. Now, this next, for y2, what I'm going to say is I want x plus y1. But since I really can't put y1 in here, I'm going to put negative 112 divided by x. And I'm putting it in parentheses. You don't need the parentheses. I'm putting the parentheses there so you can see x plus y1. So this first equation, I'm finding the second factor. The second equation, I'm adding the factors. So remember, I need things that multiply to negative 112, but then add to negative 6. So what I'm going to do is I'm going to look in the y2 column, okay? Bring that back up. I'm going to look in the y2 column for negative 6. Where is that? Do you see right here where it says table? Second table. This is x. This is y1. 0 times y1 would give me negative 112, which is not, obviously, can't do that. You can't divide by 0. 1 times negative 112 gives me the negative 112, and if I add them together, I get negative 11. 2 times negative 56 is negative 112, and if I add them together, I get 54. So this column right here, y2, is my sum column. Here are my up and down arrows. I'm just going to go down until I see negative 6 in the y2 column. Here it is. This tells me 8 and negative 14. So 8 and negative 14 are the factors. So here's x minus 14, x plus 8. And again, 8 times 14, probably not those multiplication facts that just come right off the top of your head, especially in the middle of a test. But here you have it. So that's a way to go through and do it. I'll do it a couple more times, not necessarily on all of them, but at least on some of them. Now I've set up the factors, and I'm going to solve. I'm going to set each factor equal to 0 and solve. Why did I put an x through the negative 8? Well, x equals 14 makes sense. 14 up here, and then 14 minus 6 is 8. 14 times 8 is 112. If x is equal to negative 8 and negative 14, well, that equals 112. But remember, I'm looking for the dimensions of a rectangle. The dimensions of a rectangle can't be negative. So therefore, I only have one answer that makes sense for this application, and that is the length is 14 and the width is 8. Number 2, the length of a rectangle is 1 foot more than twice its width. If the area of the rectangle is 300 feet, find the dimensions. Setting it up, here's my width. Twice the width, here's twice the width, one more, plus 1, okay? 1 foot more plus 1. Here's the area. So now, if I know that my area is equal to my length times my width, I know I should have 300 is going to be equal to 2w plus 1 times w. What I'm going to do is distribute the w and then subtract 300 from both sides. And here's the problem. Here's my equation. This is after distributing and subtracting. Now I'm going to divide. Oops. Now, this is where you can, this particular worksheet, the way they show it, I'm not thrilled about it because they use slide and divide, which is not, while it works, it's not really a mathematically sound method. It's a trick. I don't like the trick. So, what they've done, let's just get rid of this. What you're going to do is you're going to say, because A is not 1, I'm going to make a star. 2 times negative 300 is negative 600. B is understood to be 1. AX is 2x. 2x, 2x. Now I need factors of negative 600 that will add to 1. And again, here you can see it's 25 and negative 24. But just in case you want to see the calculator one more time so that you can do this, we go to y equals, we're going to clear the first equation and clear the second equation. I'm going to come back up here, and I need negative 600 divided by x, negative 600, that's where I got that from, divided by x. And then I'm going to want to add that x plus y1. What is y1? Negative 600 divided by x. Okay, so here's x plus y1. Now I can go to my table, and in this column, the y2 column, I am looking for the number 1. So I scroll down, getting there. Oops, there's 1. Positive 25 and negative 24. Positive 25 and negative 24. So I put 25 and negative 24. Now, this is where, so like this part and this part, this is where we're doing this. I can't reduce this fraction. This fraction does not reduce. So when I do bottoms up, I get 2x plus 25. This fraction right here does reduce to negative 12 over x. Now that I've reduced that fraction, I can do the bottoms up, and I have my factors. I set each factor equal to 0 and solve, and again, I put a big X through the one that's negative because I can't have a negative width. And so then I get my X is 12, which is my width, and then I multiply it by 2 and add 1 to get 25, which is my length. Okay? Now, these other ones, I'm just going to sort of walk through a little bit faster because I don't think you need to go quite so slow on all of these. Because it's the same basic idea, just make sure that you're drawing your picture. Number 3, the dimensions of a rectangle can be expressed as x plus 6 and x minus 2. X plus 6, x minus 2. It doesn't say which one's length and which one's width. It does not matter. I multiply this times this to get the 65. X plus 6 times x minus 2 is equal to 65. Then I have to FOIL that. X times x is x squared. I get minus 2 plus 6 is the 4x. Okay, so again, I'm going to have, oops, see if I can do this. X times x is x squared. Then I'm going to get negative 2x, and then 6x is plus 6x. This right here is how I got 4x, which is there. Okay, now I'm going to subtract 65 from both sides, and I wind up with negative 77. At this point, I need to factor, so I'm going to need negative 77 up here, 4 here. I need factors of negative 77 that will add to 4. That would be 11 and negative 7. Oops, should put those in here. 11 and negative 7. So then I get my factors. I solve. Now here when I get negative 11, I have to put it in here because negative 11, if this were 12, then I have 1. If this was plus 20 or something, I would have a positive. So I can't immediately rule out the negative until I plug it in and see, yep, that's going to make one of the sides negative. So I wind up with 7. But now here you have to be careful because 7 is not one of the dimensions. I need 7 minus 2, and that's how I got the 5. And then I need 7 plus 6, and that's where the 13 came from. Okay? The triangle. Now here, remember that the area is equal to 1/2 the base times the height. So we're working with a little bit different equation. The base of the triangle is 7 less than twice its height. 7 less is minus 7. Twice the height is 2h. Here's h. And you can replace these with x. So then I have 1/2. That's a constant. Base. Here's my base. And here's my height is equal to 102. I am going to need to distribute this to both of these, okay? And then I'm going to have to subtract 102 from both sides. So I distribute the x, and then this is where you can distribute the 1/2, or once I've distributed just the x, oops, let's do this so that you distribute the x to both of those. Now you're going to divide or multiply everything by 2. So I'm going to multiply this side by 2 and this side by 2. All right. Now when I do that, this cancels. Leave me with the 2x minus 7. 102 times 2 is 204. And then I subtract it from both sides. This keeps me from having fractions. If the 2 had gone into everything evenly, into the 2 and to the 7, I would have just divided by 2. Now, the other nice thing is I've got 2, 7, and negative 204. This, again, is where I don't like what they do. So we're going to go blah, 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 blah. We need to factor it. And because A is not 1, I need to make my star. So I'll have my 2x and my 2x. My value of B is negative 7. A, which is 2, times negative 204 is negative 408. Now I need factors of negative 408 that add up to negative 7. Well, that's just crazy talk to do in the top of your head. You can do it. You certainly should be able to do it by hand, but it's just kind of ugly. So I'm just going to come in here and plug it into the calculator. Negative 408 divided by x, and then x plus negative 408 divided by x. I'm going to go to my table, and I'm going to scout this y2 column for negative 7. Now notice as I'm looking down, because I start here at 20, I'm looking down, I don't see any negatives, but I can scroll back up, and here's negative 7. And I get 17 and negative 24. So 17 and negative 24. This doesn't cancel, so I can just do bottoms up. This cancels to x with negative 12 on top. Now, that can do bottoms up. At this point, I have x minus 12 right here and 2x plus 17 right here. X is 12 or x is negative 17 halves. Since x is the height, it can't be negative. So I've got the height. I plug in 2 times 24 minus 7, and I get 17, and that is the base. Now, here are a couple more. What I'd like to do is, at least for this first one, pause and let you try solving this one. Then come back and take a look. So go ahead and try to do this one. Just read it and see what you can do. Okay, so here we have the hypotenuse, which means it's a right triangle, is 1 foot more than twice the length. Here's my length. The longer leg is 7 feet longer, so I add 7 to it. Find the dimensions of the triangle. Now you're saying, wait, this isn't area. Remember the Pythagorean Theorem? Okay, where you get a squared plus b squared is equal to c squared. Yeah, there you go. So set it up. One leg squared plus the other leg squared is equal to the hypotenuse squared. Now here's the nice thing. You do all of this out, you get, and you multiply it out. Notice I'm going to have 2x squareds. I got a 4x squared. It's okay. Get everything to one side of the equation, and then you have a quadratic. The beautiful thing here is both sides, everything is divisible by 2. So you simply divide everything by 2, and now you need factors of negative 24 that add up to negative 5. Hopefully negative 8 and 3 came to mind. For something like this, you should not need to use the calculator. Now you're going to get x equals 8 and x equals negative 3. Negative 3 won't work, so you take 8, and you're going to come back up here, and this is where you say, if this is 8, then this is 15. 2 times 8 is 16 plus 1 makes this side 17. That's it. Now, if you went ahead and you were working on this other one over here, the height of a rectangular prism is 3 feet. The length and width can be expressed as x minus 1 and x plus 4. Again, length and width, it doesn't matter which one's which. The volume of the prism is 198. Okay, volume is equal to your length times your width times your height, right? So 3 times x minus 1 times x plus 4 equals the 198. What are we going to do now? Well, we're simply going to multiply this out. It doesn't matter. You could distribute the 3 and then multiply the binomials. You can multiply the binomials and then distribute the 3. Now, personally, I would multiply the 2 binomials first because that makes this easier. Then I would look to see, are both sides divisible by 3? Because if they are, I'm going to do that. And 3 will go into 198 evenly. So now I have x squared plus 3x minus 4 is equal to 66. If I subtract 66 from both sides, x squared plus 3x minus 70 equals 0. I factor, get my value of x. If x is 7, okay, if x is 7, let me move this guy so I can get my pen. Okay, x is equal to 7. So 7 minus 1 means that that's 6. 7 plus 4 means that this is 11. So I've got a 3 by 6 by 11 prism. Okay, and in this case, they just wanted the value of x, but if you had the other. Next up, Ken has a rectangular shaped vegetable garden that is 15 by 9. He would like to increase the length and width by the same amount. Okay, notice here, right here, is the initial garden, okay? It's 15 by 9. He's going to increase it by the same amount. So this amount and this amount are both x. Okay, that's where I got that x from. So then this whole side from here to here is 15 plus x. That's where that came from. This is 9 plus x. That's how I got this value. Now, if I find the, I'd like to increase it so the new garden is twice the current area. Well, the current area is 9 times 15. I'll put, okay, current area is that. Twice means I got to multiply that by 2. So that's where the 270 came from. So over here, for lack of a better term, I'm going to FOIL those. Then I'm going to subtract the 270. Now, in this case, you could go to your calculator and look, but you won't find a positive 24 because it doesn't factor. Well, if something doesn't factor, guess what we're going to do? We're going to use the quadratic formula. Okay, before we've just been factoring and solving, which is the easiest way. If something doesn't factor, though, use the quadratic formula. Negative b plus or minus the square root of b squared minus 4ac all over 2a. Plug the values in and simplify. 1,116 is not a perfect square, but remember, this said to the nearest tenth of a foot. So I'm going to use the calculator, take the square root of 1,116, and that comes out to 33.4066. Well, I do negative 24 plus that amount divided by 2, and negative 24 minus that amount divided by 2. And here are the two values I got. Can't be negative, okay? Because remember, I'm increasing it, not decreasing it. So it's got to be 4.7. That's the amount to the nearest tenth of a foot that I'm going to, or that, not me, but Ken is going to increase his garden by on each side. Alrighty? Now, for this one, large area minus small area. Given the diagram, if the area of the shaded region is 59 square inches, what are the dimensions of the outside rectangle? So I've got the area of the big one. So I need large area minus small area. Okay? Large area minus the small area will give me that gray area, and that was 59. How do I find the large area? 2x minus 1 times x plus 6. The small area, x times x plus 3. Boom. Now, over here I have to FOIL, and here I have to distribute. Then I combine my like terms and set the equation equal to 0. Now I'm going to look to see, can I factor? And lo and behold, whoops, I can factor. Come down here, just extend that page, give me some space. I can factor. I wind up with x is negative 13 and x is 5. X can't be negative 13, so x must be 5. So 5 by 8. Okay. So this is 5 by 8, and this guy is 9 by 11. Okay. Finally, consecutive, odd, consecutive, even integers, and just consecutive integers. Remember that positive integers go up by 2. So if my first even integer is x, my next odd integer, I have to add 2 to that. So 1, 3, 5, I add 2 to each one. If we're talking about just consecutive integers, they're not odd or even, our integers go up by 1. So that's how you got to figure that out. So here, the square of the smallest added to 3 times the larger is 24. The square of the smallest added to 3 times the larger is 24. What do you do here? Well, you're going to need to distribute, and then, and whoops, look at that. That should be a 2 there. X plus 2, x plus 2. I've got this. Subtract the 24, factor. Now here's the thing. X equals negative 6, x equals 3. Why is the negative 6 crossed out? Because I want to find 2 consecutive positive odd integers. Well, negative 6 is neither positive nor is it odd. So only 3 works. And if x is 3, then x plus 2 must be 5. Looking at consecutive integers, here's first integer, second integer, third integer, such that the product of the median integer, that's this middle one, and the largest integer, that's this one, is 72. Notice I'm not doing anything with the first integer. I'm just multiplying the 2 larger ones. I multiply them, subtract 72, factor, and I get a negative 10 and a 7. Again, consecutive positive. So it can't be negative, so 7. If x is 7, the next one's 8, the next one's 9. Okay, projectile motion. This is the last part, and then you all will be working on your own. A soccer ball is kicked from the ground with an initial upward velocity of 90 feet per second. The equation here gives the height of the ball after t seconds. H of t equals negative 16 t squared plus 90t. Negative 16 is a gravitational constant based on feet per second. 90 is the velocity with which the ball is kicked, the initial velocity, which is 90. And there's no plus or minus anything because the initial height, the ball is kicked from the ground. So the first thing I want to do is how many seconds will it take for the ball to reach its maximum height? Think of vertex. If a ball gets kicked, goes up, comes down, boop, it's got a vertex here. So x is equal to negative b, it's negative 90, over 2 times a, which is negative 16. Negative 90 over negative 32, or about 2.8125 seconds. Now, what is the maximum height of the ball? Well, remember, okay, when we do this, okay, and let's see if I can do this. Okay, HEI, GHT, there's our height, and here's our time. So What we're doing is we're looking at our graph and our ball, which went, and here it's at its highest point. This is the vertex. So I found the x value, negative b over 2a. What I'm going to do is I'm going to take whatever this x value is and plug it in to the equation to get my y value. So I plug that in, and I find out that it's 126.5625 feet. You have to think about, what is the graph telling you? What is this point over here telling me? Well, that would be the time when the ball is at 0 feet. That would be when it lands. 0 feet here started at 0 seconds, which is when I kicked it. Give the domain and the range of the function. Now remember that kicking the ball, I can't kick it before I've kicked it, and once it hits the ground, it's down, it's not going anywhere. It's limited. So, factor and zero product rule. All right, I've got my two zeros. So my domain, 0, so I can't kick it beforehand, is less than or equal to x, is less than or equal to 5.625. That's the time, that's how many seconds later it hits the ground. The range, again, the ball doesn't go underground, so it starts at 0, goes up, and then comes back down. So it goes from 0 up to 126.5625 feet. Think about the process, what's happening with this ball. Okay. Number 2, an apple is launched directly upward at 64 feet per second from a platform 80 feet high. The equation for this apple's height at time t seconds after launch is h of t equals negative 16t squared plus 64t plus 80. Negative 16, gravitational constant. 64, initial velocity. 80, the height at which it was launched. What is the height after 3 seconds? Well, t represents seconds, so I just plug the 3 in and I get my height. This one is nothing more than a plug and chug. You just have to know what t stands for. Number 3, a toy rocket is launched vertically upward from a 12-foot platform. There's my 12, with an initial velocity of 128 feet. There's my initial velocity. Its height, h, at time t seconds after launch is given by the equation h of t equals negative 16t squared plus 128t plus 12. The negative 16 again has to do with the gravitational pull of the Earth in terms of feet per second. 128 was our initial velocity and 12 is the height of the platform. You will not be asked to create the equation based on knowing all that, but if you take physics, you're going to learn this equation, and it's just good to know where the numbers came from. They're not just pulled out of the air. Now, how long will it take the rocket to reach the ground? Well, again, remember, you're thinking about your graph, okay? And it's here. The rocket goes up and then it comes down. Okay, we know that this point is at time 0, it's at 12. I don't know how high it goes, but I don't care. I want to know when it hits the ground. So this is called a 0 or a root or a solution. Okay, well, if I need the solution, I want to try factoring it. Well, it does not factor. So I'm going to have to use the quadratic formula. So negative b plus or minus the square root of b squared minus 4ac all over 2a. And I plug it all in. The rocket cannot hit the ground before it's launched, so the negative 0.093 makes no sense. The 8.093 does. This is just the quadratic formula. Right? If you're taking the SOL, it'll be on the formula sheet. I don't know if they give you the formula on an ACT or SAT. They may or may not. That's not necessarily something that's standardized. It is a standardized test. Giving the formula may or may not be. All right, so there's your answer, 8.093. Now, finally, a penny is dropped off the Empire State Building, which is 1,250 feet tall. If the penny's pathway can be modeled by the equation h of t is equal to negative 16t squared plus 1,250, how long would it take the penny to strike a 6-foot tall person? Okay, again, let's think about this. Okay, our penny starts up here and it's coming down, but we want to know when it hits a 6-foot tall person. This is 1,250 feet. Notice that there's no value for t, and that's because it's just dropped. It's not thrown down. If I threw it down, then it would have a negative velocity, okay? If you throw it up, it's a positive velocity, but just dropping it means you let it go. So the initial velocity is 0. So here, I want to know when it hits something that's 6 feet off the ground. So instead of setting this equal to 0, I'm going to set it equal to 6. Now I'm going to subtract 6 from both sides. Or, well, I could subtract 6 from both sides and then add or subtract. Either way, get this by itself. Divide both sides by negative 16. T squared is 77.75. Take the square root. In this case, well, yes, I keep telling you when you take the square root, you take the positive and the negative. Just do the positive here. Negative doesn't make sense. It will take just under 9 seconds, or 8.18 seconds, to hit the head of the 6-foot tall person. All right. At this point, if you're in class, you will likely be asked to complete the projectile motion worksheet and homework 9, quadratic applications. If you're watching this video, either as review or because you're missing class, be sure to check with me and I will get you the projectile motion worksheet and homework 9. All righty? Great.